Good day to everyone. This is RoboCat, where we talk to everyone about everything and anything related to robotics. So, today we will talk about AC generators and motors. So, do you folks know what an AC generator is?
A generator for aircon?
Not quite. But in order for us to learn more, here are our guest speakers who will help us navigate all about AC generators and motors. Welcome. Thank you guys for being on our show. So, first and foremost, can you guys define what an AC generator is for us?
Sure thing. So, based on the Faraday's law of electromagnetic induction, it is a generator or alternator that converts mechanical energy into electrical energy. This is done by rotating a stationary coil in a magnetic field around a stationary coil, with the resulting EMF depending on the amount of coil turns, magnetic field power, and rotation speed. Therefore, based on the output obtained, we classify generators as AC generators and DC generators.
So, what are the parts of the AC generator?
The AC generator has a lot of parts. First is the field, which consists of conductor coils in the field of the AC generator to get voltage and create a magnetic field. This magnetic field then divides the armature, causing a voltage that turns the generator's electrical output. Another is the armature, a voltage that is created. This component is primarily made up of wire coils large enough to hold the full load current of the generator.
Additionally, the prime mover is the component used to drive the AC generator. It could be a diesel engine, a steam turbine, or a motor. And the rotor of an AC generator is the rotating component that contains a set of conductive coils or a magnet. The rotor creates a changing magnetic field, which induces an electric current in the stator windings as it rotates.
The stator is a stationary component of the generator that, depending on the type of generator, may serve as the armature or the field. If the voltage output is produced in the stator, it acts as the armature, and if the field stimulation is used in the stator, it serves as the field. And lastly, slip rings are the electrical connections that conduct current between stationary and rotating components and transfer power to and from the rotor of an AC generator.
Wow, I see. That's interesting. Anyone else in the audience have any more questions?
With all those parts, how does the AC generator work?
So, when an armature rotates between magnetic poles, a continuously changing magnetic field induces an electromotive force or EMF in the armature. This EMF generates an alternating current that flows through the slip rings and brushes to a galvanometer. The direction of the current can be determined using Fleming's right-hand rule, and the galvanometer indicates the presence of an alternating current.
Fleming's right-hand rule. Can you please elaborate?
Fleming's right-hand rule is a technique to calculate the direction of electric current flow in the conductor when placed in a magnetic field. You can use your right hand by pointing your thumb in the direction of the conductor's motion relative to the magnetic field, and the direction of the magnetic field is shown by the direction of your index finger, with the direction of current flow indicated by your middle finger. Like that, I think.
That really is convenient.
It really is. And now that we know how it works, can you please tell us the advantages of these generators?
Sure thing. One of the advantages of AC generators is that they can be easily stepped up and down through transformers.
Another is its transmission link size, which might be thinner due to the step-up feature.
Not only that, but losses are relatively better than of DC machines in that their size are relatively smaller compared to DC generators.
Wow, that's awesome.
It is! Now that we have discussed and understood what an AC generator is, we will now move on to AC motors. AC motors convert the alternating current or electricity into mechanical power by using an electromagnetic induction phenomenon called an AC motor. This motor is driven by an alternating current. The stator and the rotor are the two most important parts of the AC motors. The stator is the stationary part of the motor and the rotor is the rotating part of the motor.
So basically, AC generators convert mechanical energy into electricity while AC motors convert electricity into mechanical energy.
AC motors may be single phase or three phases. The three phase AC motor is commonly used in industries for large power conversions, while the smaller single phase AC motor is commonly used for small power conversions in homes, offices, and businesses. Single phase motors are often used in everyday appliances like refrigerators, fans, washing machines, and hair dryers.
I see. So there must be different types, I'm assuming.
Yes, they do. The AC motor is mainly classified into two types. They are the synchronous motor and the asynchronous motor. Asynchronous motor converts alternating current electrical power to mechanical power and is able to run at simultaneous speed. And the asynchronous motor or induction motor is an electric motor that converts AC electrical power into mechanical power, just like the synchronous motor but by electromagnetic induction phenomenon. This motor is classified mainly into two types, single-phase induction motor and three-phase induction motor.
Both types have working principles. So for the synchronous motor, when given electricity, it creates a magnetic field that tries to make the motor spinning part move along with it. However, the spinning part is too heavy, it cannot start moving immediately, so the motor cannot start on its own. Thus, inherently, synchronous motor is not a self-starting motor.
And the working principle of the asynchronous motor is that in an induction machine, the armature winding serves as both the armature and field winding. When the stator windings are connected to an AC supply, a rotating magnetic field is produced that induces voltages in the stator and rotor winding, generating torque and causing the rotor to rotate close to the synchronous speed.
Wow, how wonderful to know that such complicated things could be of great use for us.
Indeed, that is. And with that, are there any more questions from our dear audience? I believe that everything has been answered. Then that's a wrap for RoboChat. Biggest thanks to our guests, viewers, and thanks for tuning in and exploring the world of mechanics and motors with us. Until next time, keep dreaming big and keep embracing the world of